All right. 6.3 is the proofs of parallelograms. So we are going to start with, oh, right, you wanted the 3-hole punch. I don't know what I was doing. All right, I'm trying to do too many things at once. Our objectives today, we're going to recognize the conditions ensuring that a quadrilateral is a parallelogram. 2, we're going to prove that a quadrilateral is a parallelogram. And 3, we're going to prove that 2 parallelograms are congruent using side angle side congruence for parallelograms. Thank you. Okay, so we can do, we just did this in that number 29 theorem, or on the worksheet, right? But now we have side angle side congruence for parallelograms. All right, so we are starting with lots of theorems first. Okay, so let me slide up my paper before we even get started so we can kind of see all of them. All right, so our theorems. A quadrilateral is a parallelogram if both pairs of opposite sides are congruent. So again, we're trying to prove today, our goal is like, we're given a shape, we're trying to prove it's a parallelogram. So if we can prove that opposite sides are congruent, then we can prove it's a parallelogram. Next, quadrilateral is a parallelogram if one pair of opposite sides are parallel and congruent. So if we can prove one pair of opposite sides are parallel and congruent, then we can say it's a parallelogram. A quadrilateral is a parallelogram if both pairs of opposite angles are congruent. That was a trippy one, right? All of a sudden we switched to angles. If both pairs of opposite angles are congruent, then it is a parallelogram. And the last one, a quadrilateral is a parallelogram if its diagonals bisect each other. So these kind of all came up. These are kind of the converse of what we've been doing last week.
So if we're given a parallelogram and we're trying to find if the diagonals bisect each other, we can just say yes because.
No, so in this case,
if we're given a quadrilateral.
Yes, we're given a quadrilateral. Okay. So that's what's going to happen here in example 1. Determine whether each quadrilateral can be shown to be a parallelogram. Explain your reasoning. You don't want to explain your reasoning? I'm sorry. That's kind of the basis of geometry.
Yeah, show your work is so stupid.
Show your work is not so stupid. Okay, so much easier in comparison to what you're doing now, actually. All right, so determine whether each quadrilateral can be shown to be a parallelogram. This one, the first one, has nothing to do with the theorems that you just read about, which is always fun. But we dealt with this with the last proof, the other 2 proofs that we just practiced from our homework last night. Where are the numbers? They must be placed in important places. In the angles? What angles? Are they opposite angles? Not congruent angles. Congruent means they're the same measure. They're consecutive angles. Are they interior or are they exterior? They're interior. Man, that must be special. Sounds like we do. What do we know about consecutive interior angles? Try again. You did. Okay. You did. Okay, so consecutive interior angles have to equal 180 degrees. So let's check it. 108 plus 72. What's that? Equals 180 degrees. So can we determine if this is a... It's that's supposed to be a U. It was supposed to be a U. I started my T early, and then I consecutive. There you go. All right. So is this a parallelogram? Yeah. Yes. Okay, so we did the because, so we can say yes because consecutive interior angles equal 180 degrees. And we checked it, and they do. So this is a parallelogram. So you could also know the measure of angle E now. You can know the measure of angle D. You know what sides are parallel. You list all those things. Okay, how about B? What? Ooh, they're not all congruent. So let's think through that. Which ones are, angle J and angle M are congruent. Okay, but they are also consecutive interior. So consecutive interior angles that are congruent have to be how many degrees? No, if we add them together, they have to be 180. So what would they have to be separately?
Those would have to be 90.
Those would have to be 90, right? Yeah, they would have to be. In order, because they're consecutive interior, right? So angle J and angle M have to add to be 180. But we also know, hey, J is congruent. Well, the only way they can add to be 180 and be congruent is if they're the exact same measure. Like they have to be the exact same measure.
So why are K and L said that they're different measures?
That's it. K and L says that they're different measures.
Because I thought all four had to be.
They do have to be in order to be a parallelogram. So is this a this is not a parallelogram.
But if you think about it, it is. Because like if you did K and L and the supplementary thing, it equals 90. Because you did 180 and it equals 190. K and L. Because you can do the supplementary. What?
But if theoretically, yes, but they're showing us that they're not equal. Like if we had done K and L and then we went down to JM and said like, oh wait, they're not congruent. They're showing us that they're not congruent. So we would say this is not a parallelogram because why?
Because not all of the angles are.
Well, not all the angles have to be congruent necessarily.
I thought like 3 of them had to be. 3 of the 4.
Don't have to be congruent. Right, opposite pairs have to be congruent of angles, or consecutive angles have to be congruent, or have to be supplementary. They are, but one set is, right? This set, if we say they're congruent, we know the consecutive interior angles are congruent. Assuming it's a parallelogram, we said, okay, then that means they each have to be 90. But now the problem is that L and M are not congruent. So there's no way that they sum to be 180 degrees. Does that make sense? Okay, so we can say like the consecutive interior angles are not 180 degrees. Or we could say opposite angles aren't congruent is another one we could talk about. I don't think I can write over this. Oh, I can. Opposite angles are not congruent. I didn't want to hit my record button and make it stop. Okay. All right, how about that last one? We've got 2 right angles. What's the relationship, these 2 right angles?
They're corresponding.
They're not corresponding. Consecutive interior, okay? Okay. Does it, so what else can we do from that? So they're consecutive interior angles.
Well, you can figure
Okay.
that out. Because W and C has to equal 180. So if that equals 90, then C equals 90. And then Z and Y have to equal 180. If C equals 90, then Y equals 90.
But you don't know what those are.
Okay, so this is true. So these are, again, consecutive interior angles that equal 90. So we're good there, right? But they didn't tell us that angle Z was 90 or that angle Y is 90, and we can't assume it is. So it's kind of like A or B? B? Okay. Yeah, it's kind of a combination of the two. And this one, we don't really have enough information.
So what's up?
So this one is no. Like I said, we kind of don't know if there's enough information. Angle, we could say angle Y and angle Z would have to be right angles or 90 degrees, however you want to put that in there, to be a parallelogram. It is angle Z. It kind of looks like a 2. Would it help if I drew the line through the middle? Angle Z. Now it just looks weirder, I think. Thank you for agreeing with me. I like it.
Yep.
You guys are awesome.
It's 2 with me.
I'm a fan.
It's 2 that's reciprocal.
Oh, it's there you go. It actually looks like, was it pound? The symbol for pound or something like that in
I thought it was actually
England.
2.
I usually try to curve the top, but I hate, and like a lot of times then I'll put the curve in the bottom of the 2. Like I'll write a 2 like this so people know, and then my Z's they always still think are 2s. So I don't know what to tell you. I just write poorly apparently. Okay, so let's look at the back. Example 2, find the value of each variable that ensures that each quadrilateral is a parallelogram. So we want to ensure that it's a parallelogram. So if that's the case, what do we know? So we can do that. So in example A.
So 5A equals 20.
Okay, we know 5A equals 20. These are congruent.
Are these proofs?
Nope, it just says find the value. We're just solving. And then we know what else? That 6B.
Plus 2 equals 7B minus 4.
Okay, those are congruent. So 6B minus 2 equals 7B.
Plus 2.
Thank you. 7B minus 4. So if we can solve, we divide by 5. A equals 4.
That's easy.
Right?
Darn it, I thought it was 3.
Okay. With 6B, I would subtract 6B. All right, so then we'd have 2 equals B minus 4.
6 equals B.
And then we would add 4.
B equals 6.
So 6 equals B. Kind of looks like 6 equals 6.
Now you have to go put those into the actual equation.
Right. That's what, no, not ooh. Like for the first one, 5A. So we just put that back into like one of those. So 5A equals 5 times 4 equals 20. So Q, let's see. Find the value of each no, it says find the value of each variable that ensures that each quadrilateral. So no, you didn't even have to do this. We just had to find the value of the variable. Okay, so then how about B? How would we look at B to do that one?
Y. Is that divided? Divided plus, that's plus y plus 14 equals 2x.
Y plus 14
Yes.
equals 2x. Okay, because these two sides are congruent.
Wait, what did you, wait, stop right there.
Okay.
Do 2x plus equals.
Never mind, keep going.
Okay. And then the other one should be
X plus 11 equals y.
okay. All right, but then we're stuck with this idea of we have an x and a y.
Can you put the 2x on the other side?
Wait, let's do the x plus 11 equals y, and then we'll put that into the other equation.
So you want to put this into this equation?
Yeah.
What?
Yeah, so it's substitution, remember, because it has y. We have a y here and a y here. So we're going to say x plus 11, that quantity we're replacing the y with, plus 14 equals 2x. Now we don't have a y to contend with. We only have the x's.
So bring the x over. That would equal 25 plus 3.
So I'm going to subtract x.
No, 25 equals x.
Combine like terms. 11 plus 14 is 25 equals 2x minus x is x. So you just solve for x that quickly.
And you know y equals x plus 11.
And you could have done it.
Oh, you need to find y.
I was like, we could have done this one and said, well, let's subtract 14 and had y equals 2x minus 14. You could have plugged that in over here, and then we would have had x plus 11 equals 2x minus 14. This is true. I'm just saying, you can do it a lot of different ways, but this is substitution. We do this way more in Algebra 2, which is one reason, like in these cases, the way the book sets it up, it's a struggle because you guys haven't done a lot of substitution yet. Yeah, because you're taking geometry before Algebra 2 instead. Okay, so now that we know x, though, we can plug it back into either of these. This one's simpler, so we're going to take x plus 11 equals y, plug 25 in, 25 plus 11 equals y, so 36 equals y. Does that help? Okay. All right, then we're going to look at the last part here. It is a recall. Haha. So recall that dividing two polygons into congruent corresponding triangles allows the polygons' corresponding parts to be proved congruent. Okay, and so there's a theorem down, or I printed the whole theorem on there, or the whole proof. Do what? Oh, it barely did. I was like, it didn't make it, hardly. But anyway, so it is there. So you kind of have access to that, because I didn't figure we'd have time in class to look at it. So there is the polygon triangulation theorem. Two polygons are congruent if they can be divided into congruent corresponding triangles. This is what we just did as well with the theorem 29 for your home, or the proof from 29 from your homework. We proved the triangle is congruent to turn around and prove them parallelograms. But this is saying two polygons. Then the side angle side congruence for parallelograms. So if two consecutive sides and an included angle of one parallelogram are congruent to two consecutive sides and an included angle of another parallelogram, then the two parallelograms are congruent. We could have used this earlier when we proved the sides, two sides congruent. Well, we didn't prove any sides though, did we? Oh, yes, we did. You're right. We did. We did have two sides because we use side angle side congruence of triangles. So now there's also side angle side congruence of parallelograms. What's what? The line postulate is that you can draw the line, like you draw BD. So this is saying the line postulate is just that you can draw a connector in there to talk about it. It was one way back. I don't remember the number. Maybe chapter 3. I shouldn't say way back, but chapter 3, I think. But we didn't do it a whole bunch. But that's a good question. Because, yeah, on this one, so we had the two parallelograms were given. And so they went ahead and put the sides were congruent, right? And the angle P were congruent, even though that wasn't given. That's interesting that they listed it as given. Do you see that?
It's not given.
I was like, yeah, it's not given, but they went ahead and wrote it out and listed it as given. They didn't write any sides were parallel. Oh, I guess if you look at the notation, if you look at the notation, there is a line there on these. That's why. And the angle is given. I was like, that shouldn't have happened. So it's there. It's just hard to see on the screen. Hopefully it's easier on your paper. So then, yeah, they drew BD, the diagonals, and QS, the line postulate. And then they were able to say that angle ABD, or triangle, pardon me, ABD is congruent to triangle PQRS, or PQSGs, because of that side angle side, because they had a side, an included angle, and another side congruent to a side, an included angle, and another side. And then they could say that those diagonals, BD, was congruent to QS. Then they listed all their opposite sides are congruent. Use your transitive property of congruent segments. So the fact that DC is congruent to SR, which I guess they hadn't called yeah, they knew they were parallelograms. Okay. And then side congruence for the triangles. And then they proved the polygon triangulation theorem, that two polygons are congruent if they can be divided into congruent corresponding triangles. So they proved that. Sure. Thank you. Shawl, scarf, I don't know. Has all the weird ones. All right. Then we will stop there.